Welcome to yet another episode of the Dongfang Hour podcast. I'm Jean Deville from China Aerospace Blog, recording currently from Paris. And as always, I'm joined by Blaine Curcio, founder of Orbital Gateway Consulting in Hong Kong. In this week's episode, we are going to discuss China's long road to commercial launch, and especially the development of the Long March rockets in the 80s and 90s and their first commercialization, as well as China's post-ITAR period during the 2000s and 2010s. And we will finish up this podcast by discussing the trends in the past few years in commercial launch in China, as well as how these launches could evolve and change in the years to come. Now, before we get started, let's first roll the intro.
Ladies and gentlemen, we are honored to welcome you aboard the Dongfang Hour. Please make sure your seatbelt is securely fastened. Thank you.
士们、先生们，预计空中飞行时间2小时15分钟，我们预计在当地时间下午6点25分左右到达。
Hey, this is Blaine from the Dongfang Hour podcast. Just a quick message before we start our two-part episode on Chinese commercial launch vehicles. I encourage you to check out the show notes, where you'll find links to articles, other YouTube videos that we may mention during the podcast, and also definitions on some of the phrases that we use that may not be so clear in a Chinese context. Thanks and enjoy the show.
So, Blaine, there's been a lot of excitement in launch, in commercial launch, but just launch in general, all around the world, not just in China. What is that all about, in your opinion?
Yeah, it's a good question, and I think when we consider launch as a service, I mean it's a logistics service. It's a commodity. This is if there's going to become a much larger space economy, which is you read these reports from Morgan Stanley or from the Space Foundation or from whoever, and they say that the space economy is going to grow fivefold in the next 20 years. You need a way to get there, and sort of the fundamental way to get there is launch vehicles. And over the last 10 or 15 years, we've seen in the West huge acceleration in innovation surrounding launch vehicles. So the most probably famous example is SpaceX and Elon Musk and all the things they're doing in the US. But we've also seen companies like Blue Origin, which is funded by Jeff Bezos, and a handful of smaller companies that are focusing on rather smaller rockets that have also made a lot of improvements. So basically, we're seeing this big rush globally towards launch vehicles, because this is seen as the sort of logistics method of getting to space. And China being this big growing spacefaring nation, they've been putting a lot of investment into launch vehicles also. And I guess the analog that you might make, or the analogy I suppose, is in the say 1400s, being the company that could make very large ships that could help sail to the so-called New World and kind of start that era of of exploration, if you will. I think we're at that point now with launch vehicles, and so I think that's why that's the sort of bull case to invest into a launch company, if you will.
Yeah, and just to interject on that, I think what's interesting as well is it seems to me that every country that has some sort of space industry today has at least one private startup that is developing launch vehicles and trying to grab a piece of the satellite launch cake, and I can think of half a dozen in Europe, at least a dozen in the US. You mentioned, of course, SpaceX, which is the forerunner, and of course there's China. China is also taking part in the fun of this commercial launch surge around the world. And reusability is also SpaceX, and reusability is also reshaping the entire launch landscape. And China also has a little bit of that as well, which is something we will get into. We might not talk too much about private launch vehicles in China in this episode. That is an entire topic to itself, and we'll probably dedicate a future episode to that. But there's still a lot to cover with commercial launch between the early beginnings and today. And so that brings me to my first point, which is, so before we talk about Chinese commercial launch today, we probably have to talk about the early start of Chinese commercial launch, which can loosely be set around, I'd say, the 1980s, even though we can trace the Chinese space industry all the way back to the 1950s, and China was actually one of the first countries to send a satellite to space by its own means. That was in 1970. That was with the Long March 1 rocket. But basically before 1980, so basically during the Mao Zedong era, well, the space industry and a lot of high-profile industries were an affair of, of international and domestic prestige, of class struggle, of politics, and a lot of the space programs were either, had some very unrealistic goals that were set for them, or they were extremely hampered by political turmoil at the time. And boy, there was a lot of that in the 60s and 70s. So the 1980s represents a significant switch. First, because as you know, in 1978, there's the rise to power of Deng Xiaoping, who's a much more pragmatic leader, and who, sets generally objectives in terms of mostly economic development and scientific development, and developing new technologies, and not just political and class struggle, which was the case in the during the Mao Zedong era, and so that's what the Chinese set out to do. And so in the 1980s, the early 1980s, in 1980, basically the Chinese space industry is still quite limited. I mean, China has at its disposal Long March 1 and 2. These are light rockets that are able to send small satellites into low Earth orbit, but that's basically it. And the next step up to catch up with foreign competitors is being able to send satellites into geostationary orbit, and that's extremely important, notably for comm satellites. So that's what the Chinese set out to do, and there are a lot of technical challenges in that. As you know, there's sending a satellite into geostationary orbit, you need a much more powerful rocket. You need more sophisticated engines to be able to do a number of orbital maneuvers. These orbital maneuvers, they take a lot of time, can be over dozens and dozens of hours, which means that you will be tracking your satellite sometimes not directly over your own territory, not above Chinese soil, but you will need to have tracking systems beyond China. So that's also an issue that China had. And so China in the 80s basically started tackling these problems. They among other things, they developed the YF-73 engine. It's a liquid oxygen engine, upper stage. It's one of the bigger developments for geostationary capability. They also launched the Yuanwang tracking ship. So even today, whenever China has a launch, you hear about these Yuanwang tracking ships that are leaving port in China to settle around the world. And in parallel to this, China also developed a number of new satellite platforms in the 80s, DFH-2, DFH-3, and they also developed new launch pads. So there's Xichang in Sichuan, specifically dedicated to geostationary launch, and you have Taiyuan, which is somewhat between Inner Mongolia and Shanxi, probably somewhere around the border, and so
no one really knows, do they? That's always a funny point. No one really knows which province to consider that part of.
Yeah, that reminds me of
thing. Yeah.
That's funny. It reminds me a bit of Baikonur in Russia. I mean, not in Russia, in USSR, and in Kazakhstan, which is not in Baikonur actually. And just to finish my point on these developments in the 80s, so the Chinese put all of this into place: the rockets, the satellite platforms, the launch pads, and they start launching their own satellites for domestic purposes. They launched, for example, the first Fengyun satellites for meteorology, and basically with the success of their early launchers. And the fact that at the same time there was a push from the central government in China to have SOEs, state-owned enterprises, not rely exclusively on the central government funding, but also to find commercial contracts abroad. And the fact that in the 80s you also had some issues with European and US launchers. I think you had I think you had an explosion of Ariane 4 sometime during that period in the late 80s. And you have the fact that in the 80s you don't have those cheap commercial rockets from the Russians just yet, like the Zenit. So you put all that together, and that's ingredients for international interest from satellite operators around the world, and that's what happened. There was early interest from Sweden, Australia, from Indonesia, and it actually ended up with substantial results. And in 1990, China launches their very first commercial satellite, which is AsiaSat-1, and launched in 1990. So from this portrait I'm depicting right now, things seem to run rather smoothly. But as we know, after that first launch, things sort of went not so well for China for a decade and probably more. Do you have any thoughts on the 80s, or do you want to cover the 90s, Blaine?
Sure. Thanks, Sean. Just a couple of points to add to the 80s, and then we can start talking about the fun part, which is the 1990s and all the crazy YouTube videos that have come out of that decade in China space. But just to your point in the 80s, I mean, I think one thing to be mindful of from an outsider perspective, from someone who's just thinking about China's space at that time, is that China in the late 1980s would have still been unbelievably poor. It would have been the per capita GDP. I should have looked this up off the top of my head. I would very happily wager under $1,000 per year. We can check on that, but I mean, it would have been, and I mean, we mentioned in the show notes this sort of export or die idea that applied to the space industry, because when you have a country that is so very poor as China would have been in, say, 1986, it's rather hard to devote any resources to space. And so if you are devoting resources to space, it becomes immensely easier to justify devoting resources to space if you're able to export space-related products or services and bring in U.S. dollars or other hard currency for such services. So I think certainly at that time, China would have been just a really unusual and interesting place to go for rocket launch services, because you would have just had this pretty poor country that was actually quite competent at launching rockets, as it would turn out. So really would have been an interesting time to see that. But yeah, so to your point, following some success in the 80s and then the early 90s, and I recall, just one last point finishing on the 80s and then into the 90s. I recall at one point at a conference last year in Changsha seeing a presentation from China Great Wall. And at the time, I had not realized that there was actually a fair amount of commercial space activity between the U.S. and China in the late 80s, early 90s, as you mentioned. Several launch deals made between China Great Wall and U.S. companies. And so yeah, I mean, as you had said, basically up to the early 90s, things were quite good in Chinese commercial space. It was early days, but things had gone reasonably smoothly thus far. Getting into the 90s, however, we saw things change rather quickly. So you had these two really pretty devastating launch failures in a row in the 90s. You had a Hughes satellite and then a Space Systems Loral satellite, both of which failed, both of which were American-manufactured satellites that were launched from inside of China, and both of which, following the two failures of these launches, there were investigations by the U.S. government, also by the Chinese government, but primarily the fallout came from the investigations from the U.S. government, specifically a report called the Cox Report, which basically outlined a lot of different alleged improprieties that were happening, or if not improprieties, infractions that were occurring between these U.S. companies and China as it related to things like technology transfer. And I mean, I read through the Cox report, and there were some really pretty astonishing, just odd things. I mean, you'd had situations like, inspectors were meant to be in a room at all times with the Chinese person that was looking at some documents, and they just went out for a smoking break or something. Things like this, where it's kind of like, okay, that's interesting. So anyway, these two launch failures in the 1990s. this was really pretty devastating for the Chinese commercial space sector. It made it much more difficult for them to justify, or for companies to justify launching on Chinese rockets. It made the rockets more expensive to insure. It caused a lot of people to lose faith in the ability of Chinese rockets to launch commercial missions. That being said, couple of things of note, I suppose, to our viewers. There's an astonishing YouTube video that came out of the Intelsat-708 failure. I suppose I've not watched the entire thing. It's on my list later today. But there's a team of would be people from Loral, I guess. It's Americans speaking American English and wearing baseball hats, and filming this launch failure, and then filming the next day, going out to the launch site and examining the wreckage. And it is the most surreal YouTube video I've seen in quite some time. Digressing. In the 90s, you had these two really, really bad failures, at least really bad in terms of the political aftermath. I suppose they were no better or worse than any given failure, probably. But after these failures, you had significant restrictions put in place by the U.S. government towards allowing companies to launch on Chinese rockets. Basically, you had the government of the United States saying that China had acquired certain technologies and had advanced their own satellite manufacturing capabilities through these launch failures, and as a result, it's called ITAR, the International Tariff and Arms Regulations, if I'm not wrong. And basically, it is a series of restrictions on specific technologies that are not allowed to be exported to China. And I believe some other countries as well, probably Iran and North Korea and the usual suspects. So basically, following these failures, since then, you have not had any U.S. manufactured satellites launched on Chinese rockets from inside of China, ever since the 1990s. And it's kind of an interesting thought exercise when thinking about, China did not join the WTO until 2001, so a couple of years after those failures. What might have been had China not, had those launches not failed, and had there been continued cooperation between the U.S. and China in the context of space, as economic integration between those two countries was starting to really accelerate in the early 2000s. It would have been interesting to see, what might have been, but unfortunately, we will never know. And to this day, you still cannot launch an American-made satellite from China as a result of those issues in the 90s. Have you seen that video, Jean? The 708 video. That's a crazy launch failure. I mean, you hear a lot of F-bombs in that video.
I think I think we can put it up in this podcast, in this episode. Just for our listeners and viewers to check it out. For me, it's probably one of in the top 5 more spectacular launch failures, probably on par with, I don't know if you've seen, there was a failure of a Proton rocket a couple years back where I think it was a gyroscope, a sensor that was plugged the other way around, and it's really spectacular. You see the rocket, also tilting and crashing back down. It's
Is it like Intelsat 23, I think, maybe in like 2012?
It's in the 2010s. I think it's more recent than that, but yeah, very, very spectacular. And Proton, similar to the Long March, is those Long March rockets is based on UDMH and nitrogen tetroxide, those very toxic fuels. So a very big boom. And another big boom is, but I'm digressing, makes me think of. I think it was Amos 6 that blew up on a Long March on a Falcon. No, sorry, not a Long March, on a Falcon 9, directly on the launch pad. So it was a fully fueled Falcon 9 that blew up. So yeah, I think basically the Intelsat 708 blowing up on a Long March 3B is in the same league for sure. And
that's how you know you're a space geek, when you have a list of your favorite, the most spectacular launch failures around. That's certainly a sign that you're very into space. So
yeah, sorry, but not
to get
sorry.
Some thoughts from any of our watchers or listeners have their own lists of most spectacular launch failures? We are always happy to hear.
And to get back to another point you mentioned earlier about helping our listeners and viewers imagine the state of China's economy back in the 80s and 90s, I just searched this up. The GDP of Hong Kong in 1997, so the year of the retrocession, was 18% of mainland China's GDP. And just imagine Hong Kong is 7 million inhabitants compared to mainland China, which is significantly over 1 billion. So that's just how backwards China was back then compared to today.
Oh, wow, yeah. And in 1990, I'm just looking up, the per capita GDP is $318 according to the World Bank.
That's
per year.
That's mad.
So, yeah, you could have been making, a couple thousand as a rocket scientist per year and been doing very well.
Absolutely. And moving on to the next point, which is linked to what you mentioned previously, the Cox report and the ITAR regulation that followed, which basically kicks off the second period of China's commercial space. So in the 2000s, post-2000s, and late 90s, China is in the context of extremely strict export control from the U.S. Basically, at this point, China is unable to launch any U.S. satellite, as you mentioned, but also any satellite with American components in them, and that just cuts them off from the entire international launch market. And there's a figure in the book China in Space from Brian Harvey. I looked it up a couple days ago, which mentions that in 1997, China's launch revenue was $148 million US, and that's about 10% of the launch market back then. It drops the next year to $23 million US in 1998, and to literally zero the year after that, and all the way up to 2005. So it's just to get a feel of the massive drop that you had in launch. It's although it was
and also just
sure.
Sorry, go ahead.
And it was partly compensated with the fact that China ramped up its domestic launch programs back then. You had more ComSats that were launched into orbit. There was also Earth observation and GNSS. That's also the period where China launched the Beidou, the first generation of Beidou satellites. So it's partly compensated, but still a very big hit for Chinese launch.
That's a huge number. 144 million. You said 144 million US dollars in launch-related exports in 1997. I mean, if we think about China's total exports in that year, I mean, that's 0.1% of China's total exports, which is a small number, admittedly, 0.1%. But like launch services, like when you think about how many phones China exports, or how many widgets they export, and then we just say launch services makes up 1/1000th in 1997. It's a big number.
Yeah, that's a big number for 1997.
Well, yeah, I mean, because today they must have, I presume, over $1 trillion in exports. I guess.
Yeah, we would have to do our homework on that figure.
Oh yes, yeah, a couple $100 billion per month. So yeah, that sounds about right. Okay.
And maybe to move on in the 2000s. So China was in a difficult position back then, because even though it had launch vehicles at its disposal, it couldn't provide them to foreign buyers because, well, they couldn't launch foreign satellites. So another constraint that they had is that they had to build their own satellites and sell a full package, so the launch vehicle and the satellite. And for their satellite to be competitive, they had to catch up with the international state of the art, and that's what they tried to do in the 2000s by launching Dongfang Hong 4, which is a more powerful and more sophisticated platform compared to the previous generation Dongfang 3, and which was launched for the first time successfully in 2010. That was Sinosat 6. And so you combine that together, you have a full package, and China starts marking some points in the launch market once again after the 2005. You have countries like Nigeria, Venezuela, Pakistan, Algeria, Bolivia, and so forth. And another argument that I guess China is able to put forward is the fact that, well, by buying Chinese satellites, it's also subtracting yourself from, the influence of Western manufacturers. And I think that's something that countries like Venezuela is, quite sensitive to. So yeah, they're marking a few points in the 2000s. And maybe just to finish up on those deals, another thing that you can notice by looking at these deals is most of them are, correct me of course if I'm wrong, Blaine, but I think they're all B2G at this point, and they are generally with countries where China has some sort of influence, or is a close ally of China, or maybe it's Belt and Road. That's not to say, of course, that China wasn't in competition with Western suppliers in those countries, but they are definitely not commercial Ds in the strict sense of the word commercial. And yeah, that's any thoughts on that?
Yeah, so some good points, and I think it's a very important and valid distinction to say that you have this period in the 90s, I suppose 80s and 90s, where there's kind of this naive optimism that maybe China and the U.S. will be able to get along for the long term in space, and then you have the aforementioned launch failures, and we've since had this this sort of now it's no longer new, but this starting around 2000, this next phase of the Chinese commercial space sector, whereby China is exporting these sort of turnkey packages of satellite plus launch service plus oftentimes like TT&C, like telemetry, tracking telemetry and command type of services. Also, sometimes you have things like bringing engineers from these foreign countries to Beijing to do training, this sort of thing. So they're very much turnkey in nature, and I guess it's interesting. So a couple of points. So yes, all but two should be B2G. So the Palapa N1, that was certainly a rather more commercial company. It was a consortium between 3 Indonesian companies, although one of those companies I think may have had a government stake, but still it was relatively commercial. And the other one, debatably, is there's a satellite that was sold to Cambodia that may or may not have actually been sold. It's not entirely clear what the status is, but that also should be commercial. But I guess to your point about China competing with other countries for these satellites, I think it's been an interesting thing to watch, because I think the B2G nature of these deals, it's not necessarily limited to China. So for example, if we look at, Thales or Boeing or Airbus, or, a lot of these companies, they can count on a few satellites from their kind of, if not domestic governments, like, Intelsat is obviously not a governmental agency, but I don't think they're going to buy too many satellites from Boeing. I think if they have the choice, they would buy from Thales or Airbus. Likewise, Intelsat probably would buy from Boeing or L'Oreal, etc. You also then do have these foreign satellite manufacturers non-Chinese satellite manufacturers that are competing in a similar way in some markets, and this is where it gets to be very interesting, because you look at the kind of value proposition of, let's say, China compared to the US or the French satellite manufacturers, whereby a lot of these deals, again, they're very, very turnkey in nature, and there's a much more, we touched on this a little bit last episode, but there's a much more developed kind of supporting infrastructure for these very turnkey projects. So what I would mean by that is, if, let's say, you're a Middle Eastern government or a Middle Eastern space agency and you want to buy a satellite, probably a lot of your high-level people in your space agency would have advanced degrees, and probably a lot of them would have advanced degrees from universities in the US or France or the UK. Very few of them would have advanced degrees from a university in China, I would venture to say. Some of them might be, fully locally educated, but I would venture to say a lot of them would be, again, from somewhere else. Educated somewhere else, whether it's a local Middle Eastern person who's gone to a degree elsewhere. And I remember seeing I think it was a press release for a deal between Thales and Qatar for either fighter jets or for satellites or something, and they had said we're going to do a dedicated kind of training course for all these Qatari executives at some top business school in France. So again, all these kind of auxiliary things that the Western counterparts do have already. I think we've seen China developing them. I think we see more teams of engineers from developing countries going to China for training, this kind of thing. But I do think that's an area where China has not get caught up, I guess, to the West in all of those kind of auxiliary sort of support services. Any thoughts on that?
Yeah, I think that, so as you've alluded to, China always provides a full package. That's the launch, the satellite, the ground system, TT&C, training, space insurance from probably a Chinese insurance company, and also more importantly as well, financial backing from perhaps the Exim Bank of China or the Development Bank of China. And that's a strength in itself of providing this one package to solve all your problems. But it also can be I think a major disadvantage in the sense that I think a lot of operators and clients probably, at least that's my experience in other industries, like to handpick different providers and have them working together, and don't necessarily want everything from the same source. So I think that's also something that you have to think about when you work with China. If you want to work with China, it's everything China, and you cannot have any other provider. So I guess that's one thought. And arguably another thing that's specific to Chinese deals is sometimes it's in exchange for some quite visible local influence. I guess that can also be the case for other countries, but in the case of China, you have, for example, China selling a full package to a country that perhaps doesn't have the means to pay for it. In general, in those cases, maybe a Thales or Boeing won't bid for that tender. But in the case of China, it could be, well, fine, we will cut you a deal, but in exchange you have, perhaps you give me a minority stake in your satellite operator, or perhaps you give me access to natural resources in your country. And that was the case, I think, in some countries in Southeast Asia or Sri Lanka. I would have to reconfirm. And it's definitely the case for Nigeria, where I think China took a stake in the Nigerian Satcom company.
It's interesting you bring up Nigeria. And anything else on that, or am I? Because I have an interesting.
No, it's all good.
Am I good to yeah? So with NIGCOMSAT, so I know the couple of press releases that you're referring to, probably from, let's say, early 2018 or late 2017, where NIGCOMSAT, or I should say a Nigerian minister, was quoted as saying that NIGCOMSAT would be purchasing 2 more turnkey satellites from China Great Wall in exchange for equity in NIGCOMSAT. And that's interesting. But I found out later from a contact of mine within the sort of greater Chinese space apparatus who's very much in the know about Chinese deals in Africa, that deal was never actually official, and that's kind of a minister who had kind of misspoken about the level of finality of that deal. So I do definitely recall that press release, and I do recall probably writing a little bit about that at the time, saying that seems very unusual for China to be taking a stake in a state-owned satellite operator in Nigeria like that. But I don't know to what extent that actually has happened up to now. One other thing, though, that's similar to that, and this is, it goes to your point of what are the things that China has done to kind of lower the level of friction for these foreign companies to buy satellites from China? So one of the only, if not the only, satellite that China has sold to a European country is Intelsat, which was launched for Belarus in 2016, if I'm not wrong. And Intelsat, there's 30-ish transponders on that satellite. And China Satcom has a payload on that satellite that they basically are selling capacity in certain parts of sub-Saharan Africa, partly because in order for Bell Intersat to be able to justify buying the satellite, they needed for China Satcom to take take responsibility for some of the capacity, basically. So yeah, it's definitely interesting the extent to which China has just done very different things as it relates to to turnkey solutions. The last example I would give, a friend of mine who works for APT Satellite here in Hong Kong. It's a publicly traded it's a subsidiary of CASC/China Satcom, which is partly publicly traded in Hong Kong. And during the Laosat contract, so the satellite that China sold to the country of Laos in Southeast Asia, APT Satellite won a tender for a subcontract from China Great Wall, I believe, although maybe from China Satcom, to provide sort of the on-the-ground engineering assistance in Laos. So, I know this guy went to Vientiane, Laos a handful of times to provide sort of training and to sort of get the sort of network operations center set up and all these things. And there's a public document on APT's website that shows the result of that tender. It's an interesting, just little, relatively small contract. I think it's like, I don't know, some handful of hundreds of thousands of US dollars for a company that's a couple $100 million US dollar company per year. But yeah, there's a lot of these like small, just niche companies. Well, companies doing very niche things in very big projects. So yeah, it's certainly, there's a big ecosystem supporting this for sure. All these commercial deals, and they do end up being very turnkey, as it were.
To get back to the other satellite, the Belarus satellite you mentioned just now, what is interesting on this satellite is, the payload of the satellite, the transponders were at least in part provided by Thales Alenia Space, despite the ITAR regulations from the US, and this is in 2016. And that brings me to another point, which is that there have been, a number of European countries, despite the ITAR regulation from the US, that have wished to continue to trade with China in the space industry. And companies, and probably the most famous example is Thales making ITAR-Free space bus satellite platforms, which is basically consists in taking the initial satellite platform, depriving it of all American components, and replacing them by ITAR-free non-American components, and so that raises the price of the satellite a little bit, but that makes it compatible with launching on Chinese launchers. So that's quite interesting, and I think their satellite buses have had some success, ITAR-free satellite buses. I think they've sold to APT, to China Satcom, and even to Intelsat, based in Paris, which launched an ITAR-free satellite. I think it was in 2011 or 13, on board a Long March 3, I think, Long March 3B. Anyway, so that's a very interesting trend, even though today this series is discontinued. I guess probably that's due to extra American pressure regarding this ITAR-free series, and also to the fact, I think, that China has been building more and more sophisticated variants of Dongfang Hong 4, and they've released the Dongfang Hong 5 platform this year that was launched on the Long March 5. So China more and more is becoming a competitor, and maybe is not that much interested in sending Thales satellites to space when it could be providing its own satellites. So anyway, that's a very interesting turn of events that happened in the 2000s, early 2010s, but which is today not that much of a reality anymore. Do you have any thoughts on that?
Yeah, I mean, certainly I agree that, consistent with a lot of different industries consistent with a lot of different industries, the Chinese government and in this case the space program, there's a lot of desire to build things domestically and to have technological capabilities at home, and so from that perspective, yeah, I think it's certainly, we have probably seen the peak of the ability for European satellite manufacturers to sell kind of like payload type things into China. I would have to imagine that China's capabilities in that have gotten to be sufficiently good. I suppose there would certainly be some opportunities, but yeah, I think definitely as is the case in many industries, there's an increasing amount of doing things domestically.
And before we head to the conclusion, maybe, well, I can give a quick overview of the new generation of rockets that China has been developing in the 2000 and 2010s. We've spoken about Long March 3, 2, 3, and 4 in the 80s and 90s, but there's a new generation coming up. So apologies to the listeners that are listening to the audio version, because I'll be using a quick infographic that was put together by Bryce Space and Technology on Chinese launchers, but I'll try and be as descriptive as possible. So let's dig into this a little bit. Basically, the most used rockets in China are, even today, are Long March 2, 3, and 4. These are the older generation of rockets. They've been the main workhorse of China for the past 20 or 30 years. They're all liquid propulsion and based on UDMH and nitrogen tetroxide, a very toxic fuel that was very popular back then, notably in the USSR in the 70s and 80s. And so you have Long March 3 that's used to launch into geostationary orbit, and Long March 2 and 4 that are more geared towards sun-synchronous orbit and low Earth orbit. But as you can see on the right, the Chinese have been developing a new generation of rockets. So the Long March 5, 6, 7, and 8. These are based on a new generation of engines developed in the 2000s, so using alternative fuels such as kerosene and liquid hydrogen. So Long March 6, 7, and 5, in that order, are respectively the light, medium, and heavy launch vehicles of China. And they should progressively replace the Long March earlier rockets. And notably, they have multiple advantages. First one is not using UDMH, extremely toxic fuel. There's also the fact that they are, for at least Long March 5 and 7, they are launching from Wenchang. So Wenchang is a launch pad that's in Hainan, and that's close to the sea, which means that boosters will be crashing down into the sea after launch and not onto potentially inhabited areas of Sichuan or of Shanxi when they launch from the older launch bases. And so yeah, multiple advantages, also more payload capacity. That's pretty straightforward.
Also a high degree of modularity, right? There's a lot of modularity between these rockets. So, sort of the booster for the Long March 5 is used also for this. There's a lot of common elements across the different rockets, if I'm not wrong. Is that...
That is correct. You have the same engines that are used in Long March 6 and 7, and those engines, kerosene liquid oxygen engines, are also the boosters of Long March 5. So there is a lot of modularity. Although that was also the case in part for the previous Long Marches that used the similar UDMH and nitrogen tetroxide engines for different stages. And you have this, one odd man, which is the Long March 11, which is the only solid rocket of the Long March family, and which has, as its solid propulsion, has the advantage of having more flexibility when setting up the launch. So that's that. That's about the bulk of all Chinese state-owned rockets, at least.
Well, I guess on that note, and also I like the transition with the Long March 11, because I suppose that the question I would have with 11 in particular, but it's also kind of a bigger question, is what role does the Long March 11 have? Because we have 10 private launch vehicle companies, many of which are building relatively small, solid rockets that are, pretty comparable to the Long March 11 in terms of payload mass and sort of specifications. A lot of these commercial companies are also building liquid-powered rockets as well, and this is certainly something that requires at least an entire episode on its own. But just to kind of pivot and give a little bit of a taste of what's going on in the commercial sector today, and kind of to conclude what's going to happen moving forward, we think. You're seeing a crazy number of commercial launch vehicle companies in China. I mean, we've seen investment in this sector go from zero from the beginning of time till 2014, investment was zero. Since then, according to a recent report that we published with Euroconsult, the total funding for commercial launch companies since late 2014 in China has been at a minimum about 6 billion yuan, so like $850 million US dollars, and at a maximum it would be more than 7 billion yuan, so more than $1 billion US dollars. And these commercial companies are, I mean, launch, as I mentioned at the beginning, it's a bit of a logistics industry, and to that extent, it's rather commoditized. You're getting a thing and taking it from here to there, and the parameters that you're looking at would be like, when can you get it taken to there by, and how safely can it be done by, and at what cost, and how these kind of things. It's fairly commoditized. And so moving forward, we will likely see a lot more commercial companies coming into the market, but I don't know how many of them we will see survive for the long term. We have seen a few of these commercial launch companies sign some contracts, or some MOUs, I should say, with some foreign customers. Landspace probably has signed the most MOUs with foreign customers. I think there's about 4 of them: Space Inventor and Goma Space, and then D-Orbit and Open Cosmos, all of which are European, as far as I should be. And then, so basically, I suppose moving forward, and again, presumably into the next episode, we will be discussing a lot of commercial launch companies, because there are a lot of them. And while we have discussed the history of China's commercial launch during this last 40 minutes, and while the history of China's commercial launch is largely CASC and China Great Wall, the future is likely to be quite a bit more diverse in terms of the players involved. So that's certainly something I'm looking forward to, is digging more into that topic. Anything from you, Jean, on that commercial launch or anything else?
I would definitely agree that is one of the big questions that I have for Chinese commercial launch in the years to come. How much space is China, the central government, and more specifically CASC, ready to give these private companies or these alternative players? Are we heading more into a model that could resemble at least a tiny bit to the US, where we have private launch companies providing services, or is launch services really linked to sovereignty and going to be only the sole purpose of CASC and perhaps CASIC in the future? So I think that's one question. Another 1 or 2 questions that are raised for me for Chinese commercial launch, or launch in general, is the fact that SpaceX brought the trend of reusability, and has proven that reusability is a way to bring the cost of access to space down very significantly. And when we look at the rockets that China is producing, the private companies sure are working on reusable rockets for most of them. But when you look at the state-owned ones, Long March 5, 6, 7, none of these are reusable, and they're the new generation rockets, and they haven't even really entered cruise speed. They're not launching that much. So there's Long March 8 that's supposed to be reusable, but we hardly know anything about it, and it hasn't launched yet. So for me, that's another question. And another big question mark for me is the fact that there could be potentially delays. There's the failure of Long March 5 in 2017 that delayed the launches of some important satellites and spacecraft in China. And they have their problems pretty much solved. They launched successfully earlier this year, Long March 5B. But for example, the Long March 7A, which is a variant of Long March 7, failed this year, carrying, I think it was Palapa N1. And well, if that's linked to the rocket engines of that specific rocket, which is the YF-100, YF-115. Well, those engines are also on the Long March 6 and also in the boosters of the Long March 5. So, you ask yourself, if that is the engine, if it's a deep-rooted problem, well, that could delay the Chinese launch family, new generation launch family, by another couple of years, and that would be catastrophic in terms of launching Mars missions. Also, the Dongfang Hong 5 new satellite platform, it's a satellite platform that weighs between 6 to 9 tons, and so no Chinese rocket can launch such a big satellite except Long March 5. So a lot of questions that will probably get answers in, I believe, in less than 2 years, and so probably a lot of material for future episodes, I guess.
Yeah, and the disadvantages of modularity, having the same engine in all of your rockets, and when that engine fails, it grounds the whole fleet. That's interesting. Well, I think I think we're about About on the hour.
We are about to sign off. That's about the 1 hour mark. So thank you for watching. And if you have any questions, feel free to send us an email to dfhour@gmail.com. That's dfhour